This video is on factoring. These are polynomials in the form of ax squared plus bx plus c, where a is greater than 1. So all the factoring we've done so far, a has been equal to 1, but in this example, for example, here I have 3x squared plus 8x plus 5. The leading coefficient, we call it, is greater than 1. So in the previous examples we did, we always had 1 here. So now I'm going to show you what happens when you have a number out front. So let me back up for a second, just to show you where we've been. So when you're multiplying two binomials, you use the FOIL method. You multiply the first terms, that's x squared, the outer terms, 2x, the inner terms, 5x, and then the last terms, 10, and you combine these two terms, the outer and the inner, and you get x squared plus 7x plus 10. And then after that, after we learned how to distribute, then we learned how to factor. We were looking for two numbers that multiplied that made 10. So we did x, and added up to 7. So we know that 1 times 10 is 10, and we know that 2 times 5 is 10, but 2 plus 5 makes 7. So we have plus 2 plus 5. And this is factoring, going backwards, going back to where you started. So we have distributing, and then we have factoring. What I want to look at today is when you have something more like 3x squared plus 5 times x plus 1. So you can see here we had x and x, and that's what we've been dealing with, x and x. But now what if you have, oh, I didn't mean to put that squared there. What if you have 3x plus 5 and x plus 1? So instead of x and x, now you have a 3 here. Well, let's see how that affects things. So 3x times x is 3x squared. That's the first terms. 3x times 1 is 3x. 5x times 1 is 5x. And 5 times 1 is 5. And when I combine the middle two terms, I now have 3x squared plus 8x, that's these two, plus 5. So multiplying the first two terms gets me this first term. Multiplying the last two gets me the last term. This 8x comes from the outer and the inner. Just like it did before, this outer and this inner gave me the 2x and the 5x, which made this 7x right here. But now you can see that this 3 times 1 giving me 3x, and the 5 times 1 it gives me 5x. So this affects things here. It makes a difference here if I switch the 5 and the 1. It didn't make a difference over here if I switched the 2 and the 5, because in either case you were multiplying by 1. But now if you move the 5 over here, you'd have 3 times 5, which would affect things. So the order makes a difference. So now if I had started with this and I asked you to factor this, you would say, okay, well, 3 is prime, so it can only be 3x and 1x. But 5 is also prime. It can be 1 times 5, or it could be 5 times 1, which we see here. But the difference is when you do the outer here, you get 15x. And when you do the inner, you get 1x. And there's no way you can combine 15 and 1 to get an 8. So it does not factor into this. It factors into this. So let me do another example. Let's start out with 3x squared plus 11x plus 10. This will be a little harder because this is not prime right here. Okay, so when I start factoring, I make my parentheses. This is prime, so it's 3x and 1x. This could be 1 times 10, or it could be 10 times 1, and that makes a difference. It could also be 5 times 2, or it could be 2 times 5. 2 times 5. All of those make 10. All of these combinations, the first make 3x squared, and the last make this 10 right here. It's the combination of the outer ones and the inner ones that get this 11. Here you're going to make a 15x and a 2x. Well, 15 and 2 are not going to combine to make 11. Here you're going to make a 6. 3 times 2 is 6, and 5 times 1 is 5. 6 and 5 could make 11, so it could be this one. 3 times 10 is 30. 1 times 1 is 1. 30 and 1 will not make 11. And 3 times 1 is 3, and 10 times 1 is 10. 3 and 10 won't. So it's got to be this one right here. And everything's positive, so that makes it easy. And so you can see 3x times 1x is 3x squared. 3x times 2 is 6x. 5 times 1 is 5x, and 6x and 5x is 11x. And 5 times 2 is 10. So this is how you factor this polynomial. And it takes this trial and error to find the outer and inner combination that give you this middle term. Okay, let me do one more example using similar numbers. I'll use the same 3x squared minus 7x minus 10. So again, I can just look at the same example here because all of these make 3x squared and all of these combinations make 10. We're looking for this 7 here. So this we said was 6 and 5. That won't make 7. This was 3 times 1 is 3 and 10 times 1 is 10. So we know that a 3 and a 10 can make 7 as long as I have the right signs here. So because I want it to be negative 7 in the middle, let's try this. This gives me 3x times 1 is 3x. And negative 10 times 1 is negative 10x. And you can see that when you combine these, you get negative 7. And this negative 10 times 1 gets me the negative 10. So this is how you factor it. Let me rewrite that over here. You get 3x minus 10, 1x plus 1. That's how you factor it. So it's the same kind of factoring that's going on here. You're just looking for two numbers that multiply make the first term, two numbers that multiply that make the last term, and then the outer and inner combinations have to give you this middle term. So that's factoring where the leading coefficient is greater than 1.